Okay, we've been looking at limits. There are two other big ideas in calculus, namely derivatives and integrals. But if you notice, question 1 is a limit problem. So let's take a look at a limit problem with an equation that doesn't have any strange behavior. If you notice, there's no holes or asymptotes in this graph. So the limits here are relatively easy to do. You can do the same thing. You can trace it from both the right side and the left side, and you can see that they both match up. And then you find the y value of that. So the limit here would be equal to 70. That's where the y value of where the two sides mesh up. Question 2 says, what would the unit be used for this limit measurement? Well, if you notice, that's the same as the y value here. So that would be square inches. Okay, the next question asks, what would the area of the square in this unit be? So let's take a look at this picture here. And if we notice here, it looks like it's going across by ones, because if I put in enough tick marks there, it seems to be going across by ones. Going up, well, it looks like a pretty good approximation here is tens. It looks like it's going up by tens. So that means the area of this one square is 10 by 1, which gives me 10. Units wise, this was square inches on the y-axis times inches on the x-axis, which comes out to cubic inches. So that means the area of one of the one square is equal to 10 cubic inches. And that's the answer to question 3. So the units kind of give me a hint of how to find the definite integral. Reminder that the definite integral measures the area under the curve. So if I were to count all the squares that fills in that blue area, the area would give me some number in terms of cubic inches, which is almost always associated with volume. So we must be measuring the volume of whatever this object or situation is talking about. Okay, the last two questions deal with the last big idea, which is a derivative. A derivative, there are two definitions of a derivative. Hopefully later on you'll figure out why they sound different, but in reality are the same. The first definition is instantaneous speed, the idea of taking a picture of a moving object and determining how fast it's moving by looking at only the picture. If you can imagine for a second there, that's a pretty tough concept to do, because if you take a picture, a still photo, it's not moving. How am I going to calculate how fast the object is moving? Well, that's what calculus is all about. That's what we're going to do, is find instantaneous speed. The other definition of a derivative is what we call the slope of a tangent line, which I will show an example of that here in just a second. But basically a tangent line is a line that intersects a curve at one spot only, and it closely models the behavior of the curve near it anyways. Okay? So if I use that definition for this point, and I find the derivative at x equals 5, I go to x equals 5, and I'm going to draw a tangent line. The tangent line has to intersect at that one point, and it also has to follow the behavior of the curve. So you notice there's a line that intersects at this point and this point only, and for points close to that, it's basically parallel. It's not really parallel because we're talking about lines and curves. The idea is it goes in the same direction as the curve does near that point. Okay? So the derivative in this case would measure the slope of the tangent line. Then question 6, would this answer be positive or negative? Well, if you notice, the line is going down, so the derivative would have to be negative. So as you can see, this one problem kind of gives you a preview of each of the three big ideas of calculus: limits, derivatives, and integrals. So let's remind ourselves what a derivative is. And I would again put notes, these kind of notes into your journal. Okay? So the first definition of a derivative is the slope of a tangent line. Which reminder that tangent line is a line that intersects the curve at one spot and one spot only, and it must closely model the behavior of the curve for points close to it. So in other words, if the curve is going up, the line will be going up. If the curve is going down, the line will be going down. The second definition of a slope of a derivative, is instantaneous speed. The idea of taking a picture of a moving object and calculating its speed. A very, very difficult concept if you stop and think about trying to calculate the speed of a still photo. Okay, for the integral, what you need to know is that the integral always measures the area under a curve. Okay, so the two big ideas of calculus that you need to be aware of are derivatives and integrals. Derivatives actually has two definitions. This one, by the way, is called a geometric definition, and this one is called the physical definition. And then an integral is the area under a curve. There's another definition of an integral that we'll talk about later on, but for right now, that's all we need to concentrate on.